first topic, network configuration for data security. A company needs a solution to back up data that is generated by the Java application to the local disk. The data must be transferred from on-premise to cloud storage by using SCP. A security policy requires the encryption of the data in transit and at rest. Which two configurations must be implemented to meet the security policy requirements? The next topic, DNS record type and reverse proxy. Which DNS record type allows a reverse proxy to communicate to a backend component without specifying the port? Okay, the last topic, network traffic distribution. Which networking component distributes traffic across servers? Hello everyone, this is 591 Lab, Cisco Certified DevNet Associate class. The certification number is 200901. Firstly, let me tell you about 591 Lab. 591lab.com, pronounced as 591 Lab, is a top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and 49 exam tracks. Then let's look at today's agenda. First one is network configuration for data security. The second one is DNS record type and reverse proxy. Next is Cisco Compute Management Platform. And the next one is version control system. Then edge computing. The last one is network traffic distribution. Okay, let's look at the first topic, network configuration for data security. A company needs a solution to back up data that is generated by the Java application to the local disk. The data must be transferred from on-premise to cloud storage by using SCP. A security policy requires the encryption of the data in transit and at rest. Which two configurations must be implemented to meet the security policy requirements? Option A, VPN for the Java application. Option B, encryption of the remote file system. Option C, TLS for the Java application. Option D, encryption of the local file system. Option E, IPsec for the Java application. For option A, using a VPN for the Java application helps to establish a secure encrypted communication channel between the on-premises environment and the cloud storage. This ensures that data transferred between the Java application and the cloud storage is encrypted in transit. For option B, encrypting the remote file system ensures that the data is encrypted at rest. This means that even if the data is stored on the cloud storage, it is in an encrypted form, meeting the secure policy requirement for data at rest encryption. For option C, transport layer security, that means TLS, is a protocol that provides encryption and data integrity for communications over the network. Using TLS for the Java application ensures that the data is encrypted in transit. However, in the context of the given requirements, a VPN might be a more suitable solution for the entire connection between on-premises and cloud storage. For option D, while encrypting the local file system is generally a good practice for securing data at rest on the on-premise side, it does not directly address the security policy requirement of encrypting data in transit to the cloud storage. For option E, IPsec is a suitable protocol that can be used to secure IP communication. It can provide encryption for data in transit. However, in this scenario, a VPN is a more common and suitable approach, I think, for establishing a secure communication channel. So the two correct answers are A and B. The next topic, DNS record type and reverse proxy. Which DNS record type allows a reverse proxy to communicate to a backend component without specifying the port? Option A, CNAME. Option B, PTR. Option C, AAAA. Option D, SRV. Let's break down it. The CNAME record is used to map an alias as like subdomain to the canonical domain names. It's mainly used for creating alias of domain names, but it doesn't provide a way to specify ports for communication. For option B, PTR, the PTR record is primarily used for reverse DNS lookups. It reverses an IP address to a domain or host name. For option C, the AAAA record is used to map a domain name to an IP version 6 address. It's the IPv version 6 counterpart to the A record. For option D, the SRV record is used to specify information about the location of services in the domain. It includes information such as the host name and port number where the service is available. So in the context of the question, the correct answer is D. SRV records allow you to specify both the host name and port for a service, making them suitable for scenarios where a reverse proxy needs to communicate with the backend component without specifying the port. The next topic, Cisco Computer Management Platform. Which Cisco Computer Management Platform controls server, network, storage, and virtual resources, with policy-driven management for up to 10,000 physical Cisco servers? Option A, UCS Director. Option B, Cisco Intersight. Option C, UCS Central. Option D, Cisco DNA Center. Okay, let's break down it. Cisco UCS Director is the management and automation solution that provides centralized control and orchestration of Cisco's converged infrastructure components. It is designed to manage servers, networks, storage, and virtual resources through a single panel of glass. UCS Director allows administrators to define policies for resource allocation, automate workflows, and manage up to 10,000 physical Cisco servers. It supports Cisco UCS servers, Cisco Nexus switches, and virtualized storage platforms. For option B, Cisco Intersight is a cloud-based management platform for Cisco's data center infrastructure. It provides a centralized and intelligent way to manage Cisco UCS and HyperFlex systems. Cisco Intersight offers features such as monitoring, alerting, automated policy-based configuration, and integration with Cisco's support services. It is designed to simplify operations and enhance the overall management experience by leveraging cloud-based capabilities. For option C, Cisco UCS Central is the management platform that provides centralized management for multiple Cisco UCS domains. It is designed to simplify the management of a distributed Cisco UCS environment by allowing administrators to manage policies, configurations, and firmware updates across multiple UCS domains from a single interface. UCS Central is particularly useful in scenarios where organizations have multiple data centers with separated UCS deployments. For option D, Cisco Data Center. So Cisco Data Center is not specifically focused on managing servers, but rather than managing network infrastructure. It is the central management dashboard for Cisco's digital network architecture, providing network automation, assurance, and analysis. So DNS Center is used for managing Cisco's enterprise network devices, implementing policy-driven network configurations, and gauging insights into network performance. So let's give a summary. UCS Director is a comprehensive management platform for Cisco's converged infrastructure, including server, network, storage, and virtual resources. Cisco Intersight is a cloud-based management platform specifically designed for Cisco UCS and HyperFlex systems. UCS Central is focused on providing centralized management for multiple Cisco UCS domains. DNS Center is primarily designed for managing enterprise network. So the correct answer is A, UCS Director. Okay, next topic, version control system. What is the advantage of using the version control system? Option A, it allows multiple engineers to work with the same code. Option B, it allows developers to write effective unit tests. Option C, it provides a system to track user stories and allocate all backlogs. Option D, it provides tooling to automate application builds and infrastructure provisioning. So let's break down it. For option A, this is significant advantage of version control system. They enable cooperation among multiple developers by providing a centralized repository where everyone can contribute to the codebase. Version control allows developers to work on different parts of the code at the same time, merge their changes, and resolve any conflicts and that may arise. So this promotes teams collaboration and helps in managing changes to the codebase efficiently. For option B, while version control systems themselves are not directly related to writing unit tests, they do play a role in managing and tracking changes to the code. So version control system can help developers keep track of changes, revolt the previous state if needed. But they cannot write unit tests. Unit tests also written by the developer. For option C, tracking user stories and managing backlogs is typically associated with project management tools rather than version control systems, which, while version control system may contain information about the changes made to the codebase, it is not the primary tool for tracking user stories and managing project backlogs. Project management tools such as Jira or Trello are more suitable for this purpose. For option D, while version control system may not directly automate application builds and infrastructure providing, they often integrate with CI/CD tools that handle these tasks. These tools use version control systems like GitHub to trigger automated builds, run tests, and deploy applications. The version control system plays a crucial role in providing a reliable source of code for these automated processes. In summary, option A is correct as version control system indeed enable multiple engineers to work with the same code efficiently. The other options are less directly related to version control system or involves the use of additional tools for specific purpose. Next topic, edge computing. What is the benefit of edge computing? Option A, it makes use of the single data center for data processing. Option B, it places the data processing devices closer to the data center. Option C, it prevents cyber attacks from a single weak point. Option D, it reduces latency to accelerated network. Okay, let's break down it. For option A, edge computing involves distributing computing resources closer to the source of data, rather than relying on a single centralized data center. This decentralization is the key characteristic of edge computing. For option B, this statement is not entirely accurate. Edge computing involves placing data process devices closer to the data source, which could be end-user devices, IoT devices, or sensors. The goal is to reduce latency and improve performance by processing data local rather than sending it to a remote data center. For option C, while edge computing does distribute computing tasks and data across multiple locations, it doesn't necessarily prevent cyber attacks. However, it can enhance security by reducing the attack surface as data is processed closer to its source, and the potential impact of the branch may be limited to the specified edge node rather than compromising an entire centralized system. For option D, this statement is correct. One of the primary benefits of edge computing is the reduction of latency. By processing data closer to the source, edge computing minimizes the time it takes for data to travel between devices and data centers. This can be critical for applications that require real-time or near real-time processing, such as autonomous vehicles, industrial automation, and augmented reality. And I will show a simple example for you about edge computing. So this is centralized computing. A very famous example is human face recognition or human face identification by AI, artificial intelligence. So we know there is some AI program running in our cloud data center, and this is a camera on the street. So when we want to identify some human face, the camera will snap the human as the face with a JPG file or image file. The real-time data will send to the data center, and then data center run AI models, and the calculation results will return back to the camera, and then camera send some alert or other actions to do. So this is centralized computing, and there is a serious problem of this centralized architecture is that if the camera take a photo and get a JPG file, then send to the cloud center, and it used about 30 seconds. So the cloud center will calculate this results and send back. Because our network is really not very good, so it takes 30 seconds again. So we see there is a lot of latency about this architecture when network get bad. This problem will be solved in edge computing. In edge computing, this camera will take photos and calculate results immediately, and then send JPG file to Cloud Center. This is the history data. So Cloud Center uses this new data to train a new model and send back to every camera. Camera will use this new model to update it. So edge computing will mix both data center and camera to do data processing. Camera need to process the JPG file and calculate the results, and then Cloud Center will also process this JPG file and use it to update the model. Edge computing will not make this camera closer to the Cloud Center. And also, Cloud Center maybe have some system and middleware vulnerabilities as like stress 2, but this one camera will have some different vulnerability as like IoT device vulnerabilities. So for the security, there is no one weak point for edge computing. We will also defend the Cloud Center and the IoT devices. Therefore, the correct answer is D, as it accurately reflects one of the key advantages of edge computing. Okay, let's break down it. Okay, the last topic, network traffic distribution. Which networking component distributes traffic across servers? Option A, router. Option B, load balancer. Option C, switch. Option D, firewall. Okay, let's break down it. For option A, a router is a networking device that connects different networks and directs data traffic between them. So it operates at the network layer of the OSI model. Routers primarily make decisions based on IP address and critical for routing data between different networks. For option B, load balancer. A load balancer is the device or software application that distributes incoming network traffic across multiple servers. Its primary purpose is to ensure that no single server is overwhelmed with too much traffic, thus optimizing resource utilization and improving the overall performance and reliability of the system. So loading balance can operate at different layers of the OSI model, including the application layer, the transport layer, or even the network layer, depending on their type. For example, application load balancers is different from transport load balancers. For option C, a switch is a networking device that operates at the data link layer of the OSI model. It connects devices within the same local area network and use MAC address to forward data to the correct destination. Unlike a hub, which simplifies broadcast data to all connected devices, a switch intelligently forwards data only to the device that needs it. For option D, firewall. A firewall is a network security device that monitors and controls incoming and outgoing network traffic based on predetermined security rules. It acts as a barrier between a trusted international network and untrusted external network. So firewall can be implemented in both hardware and software and are designed to prevent unauthorized access, monitoring and control data flow, and establish a barrier against potential security threats. So in summary, while all these components play essential roles in networking, the ones that specifically distribute traffic across servers is a load balancer, so option B is the correct answer. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill, so review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day!